Hi, friends. Time to start a new topic. I know you are so sad that we can't be together at school, so I figured I would brighten your day by doing your favorite kind of problem word problems. I'm sure you all said that out loud at the same time I did. I just know it. Okay, so number one. How long will it take an investment of $12,500 invested at 5.75%, compounded monthly? So there's your compounded equation right there. Compounded monthly to grow to $20,000. So the A is what we were looking for in that last set of problems previously, a couple weeks ago. But now I know A. A is the amount that I now have, which in this case is $20,000. I like $20,000. So $20,000 goes in for A. P is the principal or the initial. So there's my 12,500. 1 plus my rate, well, your rate was 5.75%, goes in as a decimal, so 0.0575. Compounded monthly, so n is 12 to the 12t. And what I'm looking for is how long it's going to take. So t is what I'm looking for. Okay, so what I'm going to do is put some things into my calculator. I'm going to divide by 12,500. And when I divide by 12,500, I get 1.6. And I'm also going to put this part into my calculator. And when I put that into my calculator, I get 1.00479 to the 12t. All right, well, now I have t stuck up in that exponent. So how do I get it out of there? Well, the way to move exponents onto the line of everything else is to use the word log. Because log takes that 12t and puts it in the front. So it puts 12t in the front, and then I have log of 1.00479. Well, now I want that t by itself. So I have log of 1.6. I want that t by itself, so I divide by 12. Log of 1.00479. In my calculator, I put parentheses around that. I put parentheses around that. I am likely putting parentheses around that also in my calculator. And if I put it incorrectly, I get 8.2 years. Double check, put yours in, please. Don't just take my word for it, even though you know I'm usually right? But don't just take my word for it. I want you to practice putting it into your calculator so that you can double check you know how to put it in correctly. Number two, how long will it take an investment of $8,000 invested at 8% compounded continuously to grow to $16,000? So again, my $16,000 is my A. That's what it's growing to. So there's my $16,000. $8,000 was the initial, so that goes in for P. But compounded continuously, so that has E there. E to the R, 8% is 0.08. And then I have my t because I don't know how long. So I divide by my 8,000. I get 2 equals e to the 0.08t. And now, because it's an e, instead of using log to get 0.08t onto the line, because there's an e, I'm going to use natural log. Well, what's the base of a natural log that you don't really see? E. All right, and if I said natural log base e of e, well, that says e to the what is e? E to the what is e? Well, that's 1. So when you have this natural log of e, that's gone. It just leaves you the natural log of 2 equals 0.08t. because the natural log of e is 1. Well, now I want t by itself. So that gives me the natural log of 2 divided by 0.08. I put that in my calculator. I get 8.7 years. Number 3, The half-life of thorium-229 is 7,340 years. How long will it take for a sample amount of this substance to decay to 20% of its original amount? So I give you a hint here. The equation to find K, so I need to find K first, is half A naught. A naught means initial or the original. So half the original, half A naught, is equal to A naught times E to the 7,340K. So this gets a little interesting because there's like 2 times here. All right, so we got to do a little thinking. Well, this A naught is the same on both sides. So essentially you could divide by that on both sides and it would just be gone. So that would leave you a half equals E to the 7,340K. Well, I want K by itself. So when I take the natural log, again, gone. So I have the natural log of a half equals 7,340K. And now I want K by itself. So K is equal to the natural log of a half over 7,340. All right, well, now I know K. But I'm going to do something else because now I don't want half-life anymore. I don't want to know when it's going to fall to half of its original value. I now want to know when it's going to fall to 20% of its original amount. So I can't use that 7,340. All I really know is the 20%. I know K. Again, that A naught is the same on both sides, so that doesn't really apply. And instead of the half, it's not half-life anymore. It's 20% of its original amount. So I'm going to put in 0.2 there because it's 20% of its original amount. So 20% of the original amount is equal to the original amount times E to the KT. Well, I know what K is, but I'm not going to fill it in to the end because it's a big number. And I don't want to round yet. You could find K and it's a decimal. It's actually going to be like times 10 to the negative something. So it's going to be a something I think that's a little bit difficult to work with. So that's why I didn't even go there yet. So I'll fill in K at the end. So again, this A naught is the same on both sides. So I'm just going to go with the 0.2. So 0.2 equals E to the KT. All right, well now I can do my natural log. So that's the natural log of 0.2, wipes out that E, equals KT. And I want to know how long it takes to get to 20%. And I know what K is. I'm looking for T. So T is equal to the natural log of 0.2 divided by K. Well, in my calculator, here's what I put in my calculator. So the natural log of 0.2 over K, and K was the natural log of a half over 7,340. And depending on what program you use, Desmos is the easiest to use when it looks like this. If you're putting it into your calculator, it might get a little messy. You might want to figure out part of it first. But when you put it into your calculator, you'll get 17,043 years. If you're close to mine but not exact because you did a little rounding, that's okay. If you round K and find out what K is and then plug in a rounded value, it'll give you something a little bit off, but close. So 17,043 years. So first I found K from my half-life, essentially like a constant-ish, and then I used it to find out when it would get to 20% of its original amount. So I'm going to use that idea again here. A bird species is in danger of extinction. So it has a population that's decreasing exponentially. 5 years ago, the population was at 1,400, and today only 1,000 of the birds are alive. When will the population drop below 100? The equation to find k is 1,000 equals 1,400 e to the 5k. That's because 1,000 is my new amount. 1,400 was my initial. We started with 1,400 birds, but it's dropped to 1,000. Okay, so I start by dividing by my 1,400, and I get 0.7143. 0.7143 equals e to the 5k. So I just divided by my 1,400. Well, now I want that k to come out. So I take the natural log, and I get the natural log. The other thing you could do, sometimes it's easier, is if you want to work in fractions, that's another option too. So that 0.7143, or if you do 1,000 over 1,400, you get 5/7. So if that helps keep things straight, I always like fractions, you know that. So it's the natural log of 5/7. And then that e is gone. So that leaves you 5k. But then I'm going to divide by 5. So that will just leave me k equals the natural log of 5/7 over 5. So there's my k. Well, now I know k. And I'm going to use it to find when it's going to drop below 100. So now I have this new equation. So my new equation, I'm going to change my color for my new equation. So it's not 1,000 anymore. 1,000 is not my amount of birds. 100 is my amount of birds. So 100. And I can't use 5 anymore because that's not 5 years ago. It was at 1,400 and today is 1,000. So it didn't drop to 1,000 in 5 years. Sure, but I'm not talking about the 1,000. I'm now at 100. So I don't really know where I'm at there. So I have 100 equals 1,400 e to the k t, because my t is unknown. It's not 5 anymore. I don't know where we're at. Okay, so I divide by my 1,400. I'm going to do a fraction because we all know I like fractions. So 1 over 14 equals e to the k t. Well, I use natural log to move that. So the natural log of 1 over 14 equals kt because it wipes out that e. And now t is going to be equal to the natural log of 1 over 14 divided by k. And you know what k is from over there. So technically, it's the natural log of 1 over 14 divided by the natural log of 5/7 over 5. If you put that in your calculator, you end up getting 39.2 years. So do some thinking there. So I found k. You could plug it in, find a decimal, round it, instead of putting in this whole part here. If you found a decimal for k, this is just what k is. It's just divided by k. So if you found a decimal for k, you would just put your decimal for k down there. The same with here. This is just what k is. So if you found your decimal for k, that's fine. You could just replace that. You'll get the same answer. Okay, so do some practicing. Take a look at these again. So proud of you. Continue to be so proud of you. And it's a great day because you got to do your favorite kind of problems. So you are so welcome, friends. Okay, miss you.